For too many years we have relied on fossil fuels as the source of our energy needs. But today we realize that this source is non-renewable, and as we move forward, new technology such as fuel cells is being researched and infrastructure investigated as the answer to our dream of a renewable and clean energy source. Hydrogen is the most basic element found on the periodic table. It is an independent substance that when combined with oxygen forms water. It is the lightest weight of all gases, but is extremely flammable. Hydrogen, otherwise known as H2, is most commonly used in fuel cells. Fuel cells are then in turn used in hydrogen-powered cars, which one day will revolutionize the world.
Fuel cells have the power to change our world. At Ballard, we are dedicated to making fuel cell technology a reality, to replace the internal combustion engine in your car with a clean, quiet, pollution-free fuel cell engine. Fuel cell-powered cars look just like other cars on the road today, but they are cleaner, quieter, more efficient, and work very differently. When you turn the key, hydrogen and compressed air flow to the fuel cell module, which contains the fuel cell stack. A fuel cell engine consists of the proton exchange membrane, or PEM, fuel cell module, coupled with the systems required in a typical automotive engine. The electricity produced by the fuel cell is delivered to the electric drive system in the vehicle. The drive system converts electrical power into the mechanical energy that drives the wheels of the car. The fuel cell generates electricity that can be used to power a car, truck, bus, or other vehicle for as long as fuel is supplied. The fuel cell is 2 to 3 times more efficient than your gasoline engine and does not create pollution. Additional benefits include increased performance and onboard power, higher reliability, and greater flexibility in vehicle design and engine layout.
This animation shows the process that goes on inside an individual fuel cell. The red H's represent hydrogen molecules from a hydrogen storage tank. The orange H's represent a hydrogen ion after its electron is removed. The yellow A's represent an electron moving through a circuit to do work. The green O's represent an oxygen molecule from the air, and the blue drops at the end are for pure water, the only byproduct of hydrogen power.
A PEM fuel cell is made of a catalyst-coated membrane between 2 plates. Hydrogen is fed in on one side, oxygen on the other. The hydrogen splits into a proton which goes through the membrane and an electron which is captured as useful electricity. The proton and electron combine with the oxygen, creating water and heat. A fuel cell will operate continuously as long as fuel is supplied.
To produce power in large amounts, many of these cells are combined into fuel cell stacks. This image shows a fuel cell stack composed of 36 cells.
A single PEM fuel cell is made up of 2 plates, 2 electrodes, and 2 thin layers of platinum-based catalyst, separated by a plastic membrane, which, when fed with the fuel, reacts electrochemically to create electricity. Hydrogen from an onboard storage tank and oxygen from air are fed through channels on the plates. Hydrogen flows on one side of the membrane, air on the other. The catalyst splits the hydrogen molecule into protons and electrons. The protons can pass through the membrane. The electrons cannot, and have to pass through an external circuit, creating useful electricity. On the oxygen side of the membrane, the protons and the electrons react with oxygen from the air in the presence of a second catalyst layer, generating water and heat. By stacking together single cells, like slices in a loaf of bread, you make a fuel cell stack to produce the required amount of power.
This fuel cell car is a perfect example of a car that runs on hydrogen. Firstly, the fuel cell must be filled with pure H2O. Now the solar panels need to be heated. A halogen lamp is being used because these supply a great deal of heat, and simply because it is more time effective, as heat from the sun would take too long. By heating the solar panel, this is helping the fuel cell split the H2O into its two separate components, hydrogen and oxygen. Here you can see the water level slowly but continuously decreasing as hydrogen and oxygen fill the tanks. Fuel cells are a multi-billion-dollar market, and using hydrogen to fuel your car will alternatively be cheaper than fossil fuels. When the fuel tanks are full, we disconnect the solar panel and plug in the motor. But why does the motor run? The motor needs a current to run. If it begins to run when it is connected to the fuel cell, it means that the fuel cell generates current. But where does the current come from? If you look now, you will see the water in the tanks rising. This is only possible when the stored volume of gases is decreasing. Now things are reversed. The hydrogen and oxygen gases flow from the tanks back into the fuel cell and are converted back into water.
Just like your car, fuel cells need fuel to operate. The Ballard fuel cell uses hydrogen as a fuel, which can be produced in many different ways, and once produced can be stored as a compressed gas or liquid, or in a chemical or metal compound. Different areas of the world will create hydrogen in different ways, depending on economics and available resources. Hydrogen can be delivered to fueling stations by road, barge, rail, or pipeline, or can be made on-site at gas stations. People may one day be able to produce their own hydrogen at home. You can see there are many options available to enable the hydrogen infrastructure to grow.
It is quite remarkable what volume of gas can be produced from a single drop of water.
Fueling the vehicle is very similar to the way you refuel your vehicle today, but requires a special sealed connection before the hydrogen can be pumped into the vehicle's storage tanks. It only takes a few minutes to refuel a fuel cell car. And when fueled by hydrogen, a fuel cell emits water and heat and no pollution. Think what this means to the air around us.
In the meantime, Mercedes, along with other multinational companies, continue to experiment with hydrogen-powered cars, with the possibility of a viable passenger car before the end of the decade.